Year 10 and welcome to lesson 2 on straight line graphs, and today we're going to look at finding the length of a line segment. But first of all, here are the answers to the midpoint questions that you had last lesson. So could you pause the video and just mark your work and see how you got on, and if you've got any more than just a couple wrong, then just send me a little message in chats and then we can work out what the issue is. So pause the video and mark your work. Okay, so moving on to today's lesson, which is all about finding the length of a line segment. So this is the first thing, this line segment thing. Don't let that confuse you. It just means find the length of a line. Okay, so but this is the technical language and this is what you will often see in exam questions. So on my coordinate grid here, I've got 2 points. I've got the point 1, 2 and the point 5, 4. And you'll recognise those from last lesson because this is the example we found the midpoint for at 3, 3. And what you can see now on the screen is a line joining the 2 coordinates up, and this is what is called the line segment. Okay, so we're going to find the length of this line. Now sometimes in a question you might just be given 2 points and you might be asked to find the length of the line that joins them. And sometimes you might be given a grid with a line and asked to find the length of the line. So you need to be able to do it both ways. But however the question is phrased, it is all about the coordinates at the end of the line. Okay, so it starts very much like finding the midpoint. I'm going to start by looking at the difference in the 2 x values so that I can find the length right here, and that's going to be 5 take away 1. So this is exactly what we did when we found the midpoint. But we're not going to halve it like we did for the midpoint, because we want the length of the whole line. And then I'm going to move on to the length here. So it's the difference in the 2 y values. And that's going to be 4, subtract 2, which is 2. Now, I'm hoping you can see that this length we found along the x-axis and the length along the y-axis and the line segment itself are making a right angle triangle. And it's a right angle triangle where the line segment is the hypotenuse. It's the longest length, the side of the triangle that's opposite the right angle, which is sitting just here. So I haven't actually drawn the triangle on, but hopefully you can see what's going on here. And we know a way to find the length of the hypotenuse in a right angle triangle, and we did it not that long ago. So we're going to use Pythagoras' theorem. And that's going to be the square of the 2 smaller sides added together, and then we square root to find the length of the hypotenuse. So it's going to be 4 squared, which is this one, add 2 squared, which is this one, and then the square root of those. So that's going to give me 16, add 4, and I'm going to add those, which is going to give me 20. Now sometimes you might be asked to leave your answer in surd form, and this is what it means, just leave it under the square root. So sometimes on a non-calculator paper, that might be as far as you can get because you can't square root 20 in your head. But we can work this out if we've got a calculator, and we can round it to 2 decimal places, and the answer is 4.47. So just like I did with the midpoint, I'm going to take this example now and I'm going to generalise it. So what I've done is I've called the coordinate up here x2, y2, and the coordinate down here x1, y1, and I found the length of this line is the difference between the 2 x coordinates, and the length of this line is the difference between the 2 y coordinates. And now I can use Pythagoras. So I'm going to square x2 minus x1 and square y2 minus y1, add them together and then square root. Now I've put this in a big purple box, and at this point you should probably pause the video and make a note of this. This is a formula, and you can learn this formula. Personally, I don't use that formula because it's taking up extra brain space, and I know if I just plot the 2 coordinates I've been given and draw on a right angle triangle, I can work out the lengths I need and I can use Pythagoras. And if you do that, then you don't need to use this formula over here. Sometimes though you won't be given the line segment on a grid, you might just be given some coordinates, but that doesn't stop you because you can draw a quick sketch out and work out what your lengths are going to be. It's entirely up to you though, you might prefer to learn the formula. All right, so we're going to look at a couple of examples now. The first one, I've chosen positive coordinates, and I'm going to plot those. So this is what you might have to do. You might have to sketch out some axes and plot your coordinates on. And I'm going to show you both ways, one without the formula and one with. So I'm now going to work out the lengths of the two sides of my right angle triangle. So along the x-axis here, I've got 5, which is x2, take away 2, which is x1, and that's giving me 3. So the length of this line is 3. And then the difference in the y coordinates, 7 subtract 5, which gives me 2. So I know the lengths of the two shorter sides of my right angle triangle. And I'm now going to use Pythagoras. 3 squared plus 2 squared is 9 plus 4, which is 13. So the answer is root 13. And if I need to find a decimal answer, that's going to be 3.61 to 2 decimal places. So that's a job done. But if I'd rather use the formula, this was what it was. I've now got to put x2, which is the second coordinate here, subtract x1, which is the first one, and the same for the y coordinates. And then I've got to work these out, which is going to be 3 and 2. And then I've got to square them. And from this point onwards, it's going to be exactly the same as it is up here. So I haven't bothered to continue this. So those are your two options. Pause the video and copy down the example into your book so that you've got a structure to follow when you do the exercise. Okay, second example. I've introduced some negatives here because we have to think about this a little bit more carefully. So again, I'm going to do this first without the formula and then with the formula. And I'm plotting my point -3, -7 down here, and then 3, 5 up here. So I have to find the length of the line segment that joins these two. Now, this time, if I find the difference between the two x coordinates, I've got a little bit here in this segment, and then I've got a little bit here. And this is 3, and this is 3. So what I'm actually doing here is taking the -3, realizing that that gives me a length of 3, and then adding it to the length on the other side. So I'm ending up with a 6. And then this bit right here, well, I've got 7 that takes me up to the x-axis, and then I've got 5 beyond. So again, I'm having to add the 7 and the 5 to work out that the length of this side of my triangle is 12. So before we were doing a subtraction, but this time we're going to have to do an addition to work out the lengths. Once I know the lengths though, exactly the same, Pythagoras theorem, this length was 6 and this length was 12. So 6 squared plus 12 squared, 36 plus 144 gives me 180. And now I'm going to square root that, so 13.42 to 2 decimal places. Now, if you're going to use the formula, that's fine. But when I put in my x1 and my y1, I have to put in -3 and -7. So I end up with 3 minus -3. And that is going to become 3 plus 3. And here, 5 minus -7 is going to become 5 plus 7. And that's how come I get the same answers as I've got on my grid over here. So I end up with a 6 squared plus 12 squared, just like I did up here. And from here on, it's going to be exactly the same working as I've got up here. Okay, so your task for today, first of all, you've got question 1 here, where you're finding the length of the line segments that join the points you've got here. So for example, the first one is AB. So you're looking for the line segment that joins AB. You need to find the length of the difference in the y's, the length of the difference in the x's, and then use Pythagoras to find the length of your line. Now, if you do have access to a printer, it might be handy to print this slide off, and I'll put that in the assignment. If you don't have access to a printer, don't worry, you can do this off the screen perfectly fine. The other option, of course, is to draw this into your book, but you'll have to be really careful to make sure you plotted your points correctly, otherwise you'll get the answers wrong. Question 2 says without the use of a diagram. So the idea here is that you're practicing using the formula. Now I told you that I never use the formula. So if you don't want to use the formula, what you're going to have to do is sketch these points out for yourself and then use the same method as you've used over here. So I hope that all makes sense and we'll go through the answers for these questions next lesson.